Bending is a curve that occurs when there is a minimum of one external force and two reaction forces acting upon it. This image illustrates 4-point bending, with external forces reacting at the far ends of the bamboo barbell due to the weights, while the rack serves as the two reaction forces to prevent the bar from falling.
One of the most important parts about differentiating rotation and bending is knowing about how it's going to rotate and move. So with bending, if you act externally on it, you actually cause a moment and it'll rotate about an axis here. However, with rotation, it's either going to be 3-point or 4-point. If it's 4-point, it'll actually be rotating. So as a system, it has no net moment. It's considered at static equilibrium. However, when bending it, it's acting at 4 points. 2 are the point of force and 2 are reaction forces. At the bottom, away from the force, you're going to have tension and elongation, while at the top, you're going to have compression and the fibers are shortening. However, if you could look at this microscopically, you would be able to see a neutral axis here that's neither elongating or compressing.
When bending occurs, the fibers closest to the external force acting on the object will experience compression and become shorter. On the opposite side of the object, the fibers will experience tension and will therefore lengthen. In between the external sides of the object, there is a neutral axis that does not experience tension or compression.
As you can see, the metal spoon is more ductile and can experience a significant bend in the plastic region before breaking, as opposed to the plastic spoon, which is more brittle and cannot experience a significant bend in the plastic region, which breaks almost instantaneously. Here is another example of bending when cars are placed in a bridge shuffle.
A bending fracture occurs when a force is applied to a specific focal point on a bone to the extent that the traumatic force overcomes the elastic limit of the bone diaphysis, resulting in a break. This is a practical application of a 3-point bend where the two reaction forces occur in the knee and hip joints, while the external force acts at the point of fracture.
A Twizzler balancing on a finger is an example of 3-point bending, with gravity acting on both sides of the finger and the normal force due to the presence of the finger acting at the point where the bend is the greatest. Since Kit Kats are rather brittle, the Kit Kat snaps or fractures almost immediately after the yield point.